Hello. In this video, we're going to learn how to solve where we have two ratios compared to one another. So, we're going to start off really nice. We'll have 9/10 equals x over 30. Now, this setup kind of looks familiar where we were asked to change denominators. Let's say our denominator is 10, and we now want to make it 30. And we could do this almost in our head where we say, well, 10 times 3 is 30. And what we multiply on the bottom, we got to multiply up top. 9 times 3, x should equal 27. Now, this is nice if the denominators match up in this way, but they're not always going to. So, there's a nice way to solve these problems, always. It's not always the most efficient, but it will always work when you have these ratios. So, what I usually do is I crisscross multiply. We're dividing by 10 here. In order to undo that, we can multiply it across the equation, and now we don't have that fraction anymore. Same deal with 30 here. We're dividing by 30. We can multiply it across the equation, and we'll undo the division. So now what we will have is 9 times 30 equals 10 times x. We can't reduce across the equal sign, but we can multiply to undo the division. That's what we're doing. And 9 times 30 is 270. And we can't have x times 10. We have to get it by itself, so we'll divide both sides by 10. And now we're left with 27 equals x, which several minutes ago we figured that out with just making the denominators be the same. But that's because this was a nice problem. So, let's get a little bit more crazier, where we're still asked to solve, but our problem's maybe not so nice. Let's say we have 18 over x equals 72 over 20. Now, x is in the denominator, and we could try racking our brains what times x gets us 20. I don't actually know that, right? Or we could say what times 18 gets us 72. And we could try to figure out the mystery x here. But it's just too much work on my part. I don't obviously see what times 18 gets me 72. So I'm going to do the cheap route. I take whatever's in the denominator here, multiply it across. Whatever's in the denominator here, multiply it across. Some of you might be asking, why can't you simplify this? You can simplify when it's on the same side of the equation, but you can't simplify across the equals. Just to avoid that issue, I don't bother simplifying. See, once again, I'm saying it's not the most efficient route. It's just like default. This always works. I'll do it. So, I have 18 times 20 equals 72 times x. Now, 18 times 20 is pretty nice. We have 360 equals 72 times x. Got to get x by itself, so we're going to divide by 72. And what we do to one side, we do to the other. And now we could try to figure out what times 72 will get us 360. And you're absolutely correct if you're shouting 5 at your screen. And that's what x equals. So that's all. Now, just because that one just seemed too nice as well, let's go ahead and see an uglier one. And what I'm going to do is toss in some decimals. Just for funsies, okay? Now, I don't write the 0 in front of my decimals because I'm lazy. You can if you want to. Some people are particular about that. I have 0.22 all over t equals 0.2 all over 0.12. It's the same story. I take whatever's in the denominator and I multiply it across. Whatever's in the denominator and multiply it across. So, we have 0.22 times, and I'm going to use parentheses so it looks better, 0.12 equals 0.2 times t. And I'm going to go ahead and multiply these two things together because they're decimals and I can multiply them together. I'll do it long ways. 0.22 times 12. I got 2 times 2 is 4, 2 times 2 is 4, placeholder, 1 times 2, add up the digits, and we have a total of 1, 2, 3, 4 decimal places involved, so we move over 4 places. and add a placeholder. So this is getting a little bit messy, but it's still doable. It's just a little bit tedious. So we have 0.0264 equals 0.2t. And in order to get that t by itself, we have to undo the multiplication. So we divide by the decimal, 0.2. What we do to one side, we do to the other. And we don't like dividing by a decimal, so we're going to move that decimal point over one. What we do to the bottom, we also have to do to the top. And we have 0.264 divided by 2. And now you just got to do the long division. I'm going to go ahead and cheat. I can kind of see it going in nicely. I got 1, 3, 2, and that's what t equals. Well, this should be a t. There we go. So decimals ain't half bad either. It's just remembering all your decimal rules, but it's still just crisscross multiply. Let's try another one. So we have fractions this time involved into the mix. And this one's pretty fun. So we have 1 over 30 all over, I know, cruel, 1/5 equals 1/5 all over t. And I have a thing for t today. I don't know why. Now, before you get crazy, don't start thinking, ooh, the 1/5s cancel out. That is not what is occurring. You cannot cancel across the equal sign. But we can do our general strategy where we take whatever's in the bottom here, multiply it across, whatever's in the bottom here, and multiply it across there. So we have 1/30 times t equals 1/5 times 1/5. Now, when you write this, because you didn't do any crazy canceling that you're not supposed to do, you can see 1/5 times 1/5, nothing's going to cancel out there. When we multiply fractions, we multiply straight across. 1 times 1 is 1. 5 times 5 is 25. And we still have 1/30 times t. Now, this is not cool. We don't like that 1/30 times t, so we want to undo it. If we divide by a fraction, instead we multiply by that fraction. It's reciprocal. Because look, the 30s will go away, we'll be left with t. That's our goal. And what we do to one side, we have to do exactly the same thing to the other. So 30s are gone, we're left with t equals, and now let's reduce. 5 can go into 25 5 times, into 30 6 times. 1 times 6 is 6. 5 times 1 is 5. And there's our final answer. So we can do decimals, we can do fractions, and we can do regular old whole numbers. All is well when we solve with ratios. Till next time.